Let's see, our next question comes from, we've got Spamandla Masombuka. And Spamandla has given us an interesting question as well. So the contact process gets its name due to the contact that the reactant molecules make with the surface of the catalyst that is added at the start of the reaction. Okay, I'm not going to write that part. I think that's just information. But something to remember here, when they talk about the contact process and stuff like that, the examiners already want to see whether you know what the contact process actually produces. So then you can go to all headmasters never own schools or something like that to actually remind yourself on what's going on. But then here is Pamandla's question. Pamandla has a question. He says, there's a reaction, and the reaction is 2SO2G. As you can see, we've actually done a question like this. Let me just double check. Wasn't the last one? Yes, it's actually exactly the same thing. That we've got exactly the same reaction, but now they're asking it in a different way. So you see, guys, I would suggest you guys do past paper after past paper because the examiners are actually just changing the questions here and there, but more or less, it's actually the same thing. And then I've got O2 gas. It is in equilibrium, which is 2SO3 gas. So this is the reaction that Pamandla has given us. So now it says here, when equilibrium is reached, when equilibrium is reached at a temperature of 430 degrees Celsius. Remember, moving that to Kelvin, you just add 273. It is found that 0.2 moles, 2 moles of SO2, 0.4 moles of O2, oh, this is actually an easy question, and 0.2 moles of SO3 were formed. And now they've given us actually the correct volume, cubic decimeter, in the 2 cubic decimeter container. Okay, so this is actually a very easy question, Pamandla, but I could see where you're coming from, and they want us to calculate. KC. I mean, usually you are so used to finding a question where you have to work so hard to get the answer, but this answer is actually very straightforward, and I'm going to show you why. Let's just read it again. When equilibrium is reached, which means at the end, they've already given us everything. Now, this is what I want to do. I just want to rewrite my equation again this side. I've got 2SO2G plus O2G. It is in equilibrium, and it is 2SO3. I'm going to show you, we're going to use my method again, what you start with, what we've used, and what we have at equilibrium. But look at this question. It is found that 0.2 moles of SO2, so I've got 0.2 moles of SO2, 0.4 moles of O2, and 0.2 moles of SO3 were formed in the container, and this is when equilibrium was reached. So they're not even worried about what they initially put in or how many was reacted. They're already telling us, no, when equilibrium was reached, this is what we had in the container. So it's actually very simple, Spamandla. But I can understand why you would feel so freaked out because it's never really this easy. So now at equilibrium, we're going to calculate our concentration at equilibrium. We use the formula C is equal to N over V. My moles is 0.2 because that's the moles at equilibrium. It is in a container of 2 cubic decimeters, which is 2. We're going to find that answer. C is equal to N over V. My amount of moles at equilibrium is 0.4. It is in a container of 2 cubic decimeters. I've got C is equal to N over V. My moles at equilibrium is 0.2. And the container is 2. So now we're just going to calculate. But I mean, looking at this question, it was just for 3 marks. So it's not that hectic, but I can understand why anyone might feel like, nah, man, I must be doing something wrong. These examiners will never be this lenient. So for the first one, I get 0.1. Let me do the next one, and then I'll just remember the next one. So that was a 0.1, and 0.4 over 2 gives me a 0.2. Okay, so for this one, we got 0.1. And remember, it's mole per cubic decimeter. And for this one, we got 0.2. It's also in mole per cubic decimeter. And because of the mole ratios, in this side, we also 0.2. So I'm also going to get 0.1. And it's also in mole per cubic decimeter. But Spamanda's question is not finished. They want us to calculate the Kc. Remember, when we calculate Kc, we take the concentration, the equilibrium concentration, and then we can calculate the Kc. So when we're calculating Kc, always write it down. You've got your products, which are on the right-hand side of your equation. You've got your reactants, which are on the left-hand side of your equation. My products in this case, let me see, where's my equation? I've got SO2. Remember, the number in front will become an exponent. So I've got SO3, I think it is, squared all over my reactants. I've got SO2. The number in front becomes an exponent. I've got oxygen gas, which is a diatomic. It's only to the exponent 1. You don't have to write that. Now I'm going to take the numbers at equilibrium. For SO3 at equilibrium, I've got 0.1 to the exponent 2. I'm going to have 0.1 to the exponent 2. And then I have 0.2, which is to the exponent of 1. Now let's calculate the value of Kc. Notice, Pamela, this question was actually pretty simple, but I can understand why you might have thought that it would be difficult, because examiners are never really this lenient. 0.1 to the exponent 2. Oopsie, you never write it like that. Write 1, put it outside, open bracket, that's 0.2, and then I get the Kc value as 5. So that's the Kc value. But looking at Spamanda's question, the fact that because I see there's also a question where they ask you, define what is a catalyst. Remember, catalyst is a substance that speeds up the reaction rate without taking part. So, for example, if you guys want to braai there at home, but you want the fire to quickly come up, you put that white stuff, those fire lighters that actually become a catalyst when you are braaiing, and then it has this this big flame that you'll get. So that's what a catalyst is. Another one of Spamanda's questions was that what does the contact process produce? So that's also just another question, some of the questions that we have done, and then define chemical equilibrium. Those are all the things that we've done last week. But I was actually much interested on how we do the mathematics of these forms. But otherwise, Pamandla, this is how then you would have found your Kc. Very straightforward. Make sure that your equations and your calculations are correct. Always remember your formulas for each and every one of them. I know it sucks. And always remember your SI units for your concentrations. Otherwise, Pamela, this is how I would have answered your question. Thank you so much for the question. Just to spice things up a little bit, guys, I want to actually add this. So now, if you have a value of Kc, which is 5, what does that mean? Just like for interest's sake, just now in case they ask you, if you have Kc, which is greater than 0, it means that your equilibrium lies to the left. And this also means that you have more products. More products. So I'm just thinking now out of my head, I've actually seen a question like this where they ask you to calculate Kc, and then they ask you, what does this value of Kc tell us about where does the equilibrium lie, and do we have more products or more reactants? Now, something to remember, if your value of Kc is greater than 0, it lies to the left, it's got more products. However, if your value of Kc is less than 0, then the equilibrium will lie to the right, and which means you'll have more reactants. More reactants. And remember what we spoke about in last week's chemical equilibrium. We said, as a company doesn't want to buy so many ingredients and only produce one cupcake. No, the more that they can produce, the more money that they can get. So obviously they want a high percentage yield. They want everything on par. They want everything to decompose. In the previous question where we actually had to answer the percentage of decomposition, where we had a 92, that is a great percentage yield. I mean, they're meaning they're going to get actually a lot of money back. But guys, the value of Kc actually tells us that. What happens to the yield? Do we have more products, more reactants? And in which side or direction does then the equilibrium lie?